Okay, hello everyone. Welcome to the first online video of our spring EECS 281 semester. And I'm Dr. Paoletti. I'm going to be doing the lecture today, and Professor Darden and I are planning on me doing the Monday and Tuesday lectures and him doing the Wednesday and Thursdays. And I've got him here on Google Meet, so I'm going to switch over to him. It'll take me a second to change the audio, and we'll get a message from him.
Hey, how's it going? It's good to be here. Of course, here is my house because we're all stuck somewhere, but at least we get to have 281. This spring, we've got a record class size. We got a record staff size. It's going to be a lot of work. It's going to be a lot of fun, and you're going to learn a lot. Thanks.
Okay, so like you said, we've got record size for a spring semester. Obviously not a record size for a fall or winter, but we've got more people in the spring than ever. Speaking of which reminds me, I think, as far as I know, everybody on the wait list has been added to Canvas and the Autograder and Piazza. A few people that I got emails from that couldn't get on the wait list, they've been added. I think I caught everyone so far, but if not, we'll get those added soon. And also the history of 281, we have never turned anyone away. I don't want to start. I cannot guarantee you we will clear the wait list, but we always have before, and I want to make sure that we continue to do so this semester. So we were going to get the videos recorded. Obviously, a lot of you found where we are. I saw, what did I see? 110 people, concurrent viewers. We can't make the video stream public until after the recording. We had one recording where we had trolls in it, and that was just a pain to get rid of them. So I'm going to switch over to my iPad here, and we're going to look through some of the slides. We're going to go back and forth with a bunch of different things today. So we've got, you met Professor Darden and I. Here's the rest of our staff listed. We've got 11 staff members this spring. Some of them are brand new. Jungwon Kim is the first time he's doing 281 staff. Faye Christoph has been here, I think, for about 6 semesters. And the others anywhere from 1 to less than Faye's. Also, you'll see, I haven't hooked it up yet, but I'll have to do that later today. You'll see some posts from PotatoBot on Piazza. It's a machine learning system that tries to give you follow-ups to say, hey, it looks like your question has already been answered. You should look at @link and @link, and it'll show you like 2 other posts. And generally, like one of them will be spot on and the other one will have nothing to do with what you posted about. But the Potato's intelligence is somewhat limited. Our weekly schedule, so we plan to do the videos at our scheduled lecture time. I know that's not convenient for everyone who's somewhere other than Ann Arbor, but we have to have a time, and no matter what time we pick, somebody's going to be unhappy with the time. At least it's not like our 8 a.m. final exam, which we had people overseas and California, etc. So we ended up giving it multiple time slots. So we'll have the link in the schedule of topics, usually like the day before we do that particular lecture. Like basically I'll finish one lecture and I'll create the stream for the next one and add the link. The labs, they will be recorded and posted on our YouTube channel. I believe the first one, I know the first one has already been recorded. I don't know if it's been uploaded yet. They might be waiting for tomorrow to do that. All of our lectures and labs cover the same material. That line there, let's just cross that out. That's a leftover from like a normal semester where we'd have multiple lectures and multiple labs, sort of not applicable now with our videos. And I provided a link there to our YouTube channel. Make sure you go to the videos link, because when you go to that page, it'll show you like the most recent. Some things you'll want to see might be further down on the list, so click on videos there. And if you go to it from Canvas, we've got a link on Canvas, which I'll show you in a bit. that one goes directly to the video's link. Okay, so we've also got something we do every semester is the EECS 281 crash course. And normally we do this in person, which we can't this semester. We recorded every one of those and we posted last semester's on YouTube because when we do that video, Professor Darden and I are always doing separate parts. Like I'm doing my Visual Studio tips, he's doing Xcode stuff, and so we posted the video. For the labs, no, we're going to do pre-recorded labs because we didn't want to do 6 different recordings of them, but we're going to be having our staff doing extra office hours so that you'll have more time to ask questions about the labs. So we'll have the lab slides, we'll have the pre-recorded labs, we'll have all the exercises that you do, you'll submit to Gradescope exactly, and etc. We'll go through some of the lab stuff coming up soon. You've got the dates here for the midterm and the final. We're still unsure what we're going to do about times, whether we're going to force everybody to have them at the same time. We know you don't like that if you're in different time zones that are very odd times. So what we did last time was we had 3 time slots. The final exam was supposed to be 8 a.m. from the registrar, and we did 8 a.m., 4 p.m., and midnight. And we probably won't do 3 for spring. We might do something like 2 and put them like 12 hours apart. So that'll definitely catch everybody's waking hours, no matter where you are on the globe. So the 281 crash course, here's the things it goes over using GitLab. I forgot, I got to update this slide. We can get rid of the .eeks in there because there's a gitlab.umich.edu now. We're a little out of date on that slide. So we're going to go through how to build a project with Xcode and the things that Xcode doesn't have that you'll need this semester, how to build a project with Visual Studio and the things that Visual Studio doesn't have that you'll need this semester. And definitely, even if you've used these tools before, go through the video because we're going to be doing something get opt long, which is the command line flag. So you can say things like /hunt is our treasure hunt, and then -- options, etc. These long options are the things that we're going to have to teach you how to use. So go through that video. We'll show you how to submit to the autograder, how to read the results from the autograder, how to work with Kane, how to get started on Project Zero. We're going to go through some of the stuff on Project Zero, like how to get 2 of the functions written, how to build it inside of Visual Studio or Xcode, etc. The syllabus, please go through and read that. I don't want to do the whole thing together, but it summarizes the course policies. And a lot of this stuff we're also going to be going over today. Now, I'm going to go over to Canvas and get my camera switched over to it so I can show you some of the things on there. Okay, so on Canvas, we've got a bunch of links over here on the left. We've got the schedule of topics. Obviously, if you found our live video today, you definitely found the schedule of topics. Assignments lists everything and when it's due, grades, etc. Calendar. The calendar is where we show office hours, and Professor Darden and I are going to get some posted for this week. Generally, we'll do it like we'll have video for lecture, we'll have a break for lunch, and then we'll have office hours. So we'll probably start our office hours at 1 p.m. We've just been really busy with the grading the final from last semester and everything else. So the calendar will show you when office hours are, and we'll get some added for this week. Probably, like I said, probably like 1 o'clock. Files, very important. We're going to take a look at a few things in here. Practice exams, I'm going to populate that soon. Lab materials, I know I saw the lab 1 is set to be revealed. Lecture has our lecture slides. Project, so if you look in the project folder, you've got our makefile.txt. Obviously, it's not a text file, but it's got a link to where to find the master copy of our makefile. We've got Project Zero, Project One. Project One, Professor Darden put the entire project spec on Git. So if you go in here, it's got a link to it and an apology. Canvas doesn't have an easy way to create a link as content. You can add it in the menu at the left. Oh, but once you create a link at the left, you cannot delete it. You can't modify it. All you can do is hide it and make another one if you make a mistake. So it's a real pain to add links on Canvas. So we've got a link for the treasure hunt project one. And also there's a PDF that I posted, which is the project one, the STLNU treasure hunt version. Things in the STL you will need in order to do your project one. We got a link to Piazza. Let's see. I was going through files. Resources. Yes, resources, very important. Algo list is really cool. Lists a bunch of different STL algorithms, how to use FileZilla to transfer files. Optimization tips is very important. You're going to hear me refer to this document over and over through the semester. I'm going to say, have you looked at Canvas, files, resources, optimization tips? One student said that they were afraid that they were going to start hearing it in their dreams. So you will hear me say this a lot. Lots of useful things in here on optimizing memory usage, how to read input, how to use Valgrind, how to optimize for speed, a bunch of pages on that, code organization for speed, use of the STL, data structures, things that don't make a difference that you think might, function calls and organization. Here's another section on reading input, really specifically how to read input, and exam grade optimization. Read this now. Read the whole thing now. But also exam grade optimization right here says, treat the entire semester as prep for the exam. There's things that you can do now to get ready for the exam that don't involve doing extra work, but doing it differently. So read through that. Another thing I'm going to have to add that Professor Darden thought of is, we added it, number 2. So we added this one also. So number 2 is a little bit of extra work, not too much, but it'll help you get ready for the exam. So go through this entire document now. You won't understand all of the speed optimizations now, but it'll give you a good hints at how to start things. There's a setting up Visual Studio video. There's a Visual Studio installing and using. There's an Xcode installing and using. There's Visual Studio files, Xcode files. So take a look at all of those. And sample code has some code of things that we'll refer to throughout the semester. We'll use these examples at different points. Okay, let's see other things. Piazza, YouTube, quizzes. Quizzes is what Piazza calls it. It's basically a tool to do like multiple choice questions, things like that, and we will use the quizzes. I'm going to put it in air quotes, you can't see me, but quizzes in air quotes. Quizzes will be used for the labs. There will be parts of the labs that you'll answer in the quizzes system, but it's part of your lab grade. There's also quizzes where you'll do part of the final exam, midterm exam on quizzes. U of M course manager, I don't know what that is. Office hours help queue is how you sign up for office hours and let people know you need help. Basically, we're going to have a Profess Hours channel. If it says Profess Hours, that means Professor's Office Hours. And we'll have another Office Hours queue for the staff. The Professor Office Hours, we tend to be one-on-many answers. So at the beginning of the project, really super useful. If you've got a question that doesn't involve showing us code, Profess Hours is the right place to be. If you need help that my staff haven't been able to help you, come there also. We will do one-on-ones for Prof's Hours, but at the beginning especially, we want to be one-on-many because everybody's got questions that are about the project and how to answer them. And I'm sorry if you've got questions. If I switch over to see your live questions, you'll get like this infinite image of picture-in-picture of my screen where I can see that. So I'll check back on those as soon as I've done sharing my screen here. AutoGrader 1 and 2, we have 2 AutoGraders. They are identical hardware and software. We expect you to load balance yourselves. So if you go to AutoGrader 1 and there's 7 people in the queue, then maybe you should check AutoGrader too. Maybe there's less people there and you'll get your results a little faster. Link to Gradescope. Alternate exam request. This is for people that have SSD forms. Put it in there. If you're, since we're probably going to have, like I said, probably 2 different times for the exams, you shouldn't have conflicts for the exams. But if something comes up where like you absolutely have to be traveling at the time of an exam, let us know. We've been less forgiving of that in the past than we are in today's COVID-19 world. Teaching evaluations you can do later. The rest of that stuff hidden is my stuff. Okay, let me go back to my camera. Or no, let's go back to iPad. Okay. And now I'll go over into the live stream and see if I've got questions. Okay, looks good. So let's see. So we've got that. Prerequisites. So we do enforce the prerequisites for the course, 203 and 280. The grad student note at the bottom, there is an EECS 403, but there isn't one during spring, so we don't have to worry about that. Preparedness self-survey, it's on Canvas, quizzes. It's not a quiz. It's not graded. It doesn't count towards your grade at all, but if you haven't used Canvas quizzes before, it's a chance to see what it looks like and use it with something that doesn't affect your grade, and it's just got a couple of multiple choice questions like 4 from 203 and 4 from 280. Required textbooks, and we've got links to these in the syllabus. These textbooks, it says required, but really we should just change this to recommended. The Corman, Lyserson, Revest, and Stein is the names of the authors. You'll often hear this book referred to as just CLRS. So when we say CLRS, that's what we're talking about. It's a great book to have. In general, I kept mine from the time I was a student until the time I was professor and got a new edition. Then I gave my old edition away to one of my grad students who was on 281 staff. If you want to get a grade in 281, if you want to get credit for 281, you must enroll for a grade. If the COVID progress satisfactory grades will happen in spring, I don't know the answer to that one, Raymond, but you need to be enrolled for a grade, whether or not the COVID-19 satisfactory progress appears or not. You cannot just choose to take it pass-fail and get credit for it. You can fulfill the prerequisites with a P if it's a COVID-19 semester. And I don't know if they're going to apply those grades in spring or not. That's something I got to look up. I just thought of that. I got to look that up. So anyway, back to the book. So CLRS, great resource. If you buy a copy of this, you can keep it for the rest of your career. C++ Standard Reference Library by Joe Sudas, and that's Joe Sudas is the way we'll refer to this. There's actually really good websites now, CPP Reference and C++, the online versions, really, really good, and also let you do some code testing and editing in their website. So let's change these to recommended. As you can tell, I haven't been writing with my tablet for a while. I got to get used to writing on it again. I had a week here of doing exam stuff. Now the collaboration. So first of all, everything you submit must be your own work. You cannot collaborate on projects, although you can on labs. You can have partners on labs. You can use your partner's code on the lab. If you are retaking 281, I'm sorry that you have to do that, but if you are doing that, use your own code. It's your code. If you are retaking it and you have code from the lab from a partner, then if you'd have code from a lab with a partner, don't take another partner this semester and give them code. Any version of Joe Sudas is good if you've got it. And like I said, CPP Reference and C++.com are both awesome resources also. I don't know what the first edition of Joe Sudas, if it's missing anything. I don't know if it has Like it might not have hash tables. First edition Josudas may predate hash tables. So don't show your project code to others at all. Don't post it on Piazza. Don't use a public repository. If you're going to use a repository, that's great. Just don't make it a public repository. Test files, you can trade them around, but you're supposed to only submit your own test files. And we'll talk about test files when we talk about projects more. Honor code, you can read up on it. We hate doing it, but we will. Unfortunately, the computer science department submits more cheating cases than the rest of the College of Engineering combined. And it's not that we have bad, evil students who cheat. It's that we are really, really good at catching them. Okay, is it okay to use other references? Sure, to learn things. If you want to look at how an algorithm works, there are great references out there. There's great resources, but don't copy and paste code. We don't even have to catch you copying and pasting from a website. We just have to let some other student do the same thing you did, and then you will show up as identical to each other. So it's kind of self-policing there. Getting help and contacting us, we've got an EECS 281 admin email, so you can email that rather than emailing professors or staff directly. If you need to talk to us about something really personal, come to Prof Hours, tell us you need something really personal to talk about. We'll open up an individual meet with you. Other resources there, like I mentioned, CPP reference and C++. Piazza obviously is linked from the Canvas page. And close or mark your questions, especially follow-ups. Mark your follow-ups as resolved. Especially if another student answers your question satisfactory, mark your follow-up as resolved so we know you're happy with the answer and don't have to do more for you. That'll just help us help you faster. Come to office hours with specific questions. Conceptual questions are great. I don't understand what this part of the spec means is a very, very specific question. What we would like you to do, though, is start submitting to the autograder. Don't tell me, oh, I'm sure my project works perfectly. I just haven't submitted to the autograder yet. And yeah, I know the project is due in 6 hours. I'll submit soon. When you've got questions, let us be able to look at your code on the autograder. We've added something to our make file, which didn't make it in the video. I just thought of that. Our make file, Professor Darden just added something to our make file called make ungraded. If you do make ungraded, this is for projects. What it will do is it will put all of your code in a file, but it will leave out the make file. And when you submit it to the autograder, it won't use up a submission because there's no make file, there's no test files, but it'll get your code onto the autograder. It won't tell you if it compiles or anything, but if you just need us to look at your code and you don't want to spend a submission, make ungraded and submit the ungraded.tar.gz to the autograder, and then you'll be able to let us look at your code, your latest version of your code, without using up this daily submit. So back to the office hours. So conceptual is fine, code specific, know what works and what doesn't. Know that, hey, I can pass this simple test and this slightly more complicated one where I added 2 lines to the input file doesn't work. That's a great question that we can help answer. Come to office hours, especially proffice hours, starts with a PR. Proffice hours, the professor office hours, right after the spec is out, come with your general questions. We'll be happy to answer them. And we like to answer those questions. We've also got, if you look at the Project 1 spec, I believe it's near the bottom, it's got a link to a video, which is on our YouTube channel. You can watch a video that Professor Darden made, an introduction to the Project 1, and we'll have this for all the other projects also. So it's on our YouTube channel, and there's a link to it in the project spec, I think near the bottom. Also, when you've got questions, try not to ask all 12 of your questions in a row when there's 50 people in office hours. So we'd like to get a lot of people's questions answered, and some of the questions you have, other people will have also, but try to give other people a chance when we're going through questions. Please don't just one more quick question me for 45 minutes. Staff office hours, please respect our staff office hours. Our staff, our students also, they may be taking a class during the summer. If they go over, thank them. If they say they can't go over, they really have to leave, then respect that. They do have to be successful also. To be successful staff members, they've got to be successful students. Professor office hours, the door stuff. I didn't even think of the door stuff. Doors, obviously, we're not in our offices. Doors. Anyway, office hours help queue. And again, in the room. Okay, I forgot to update some of this stuff for not in person. So come to the office hours. In the office hours, you don't have to get on the queue. We're going to have a link to a Google Meet. Just join the professor's Google Meet and ask questions. If you need individual help for the staff office hours, they've got instructions on how to create a Google Meet, how to give them the link. They'll join you for individual questions. For the professor office hours, just join the meet, get everybody in there. I would prefer turn your mic off until you're talking. Otherwise, we'll get too much background noise captured, etc. If you hear a cat meowing, I apologize. Sometimes she likes to talk. She thinks if I'm at the table, there must be food involved. So grading, 20% from labs, there's 10 labs, 40% from projects, there's 4 projects, 20% from each of the exams. So what do you need to do to pass? So if you do this, you will pass. No matter what happens, if you do these 3 things, greater than or equal to 50% on the exams, greater than or equal to 55% on the projects, greater than or equal to 75% on the labs, you will pass. And yes, there will be profs hours today. We haven't put them in the calendar yet. Like I said, we've been terribly busy. Yes and yes. So yes, there will be profs hours today, probably 1 o'clock, maybe 12:30. We'll see when Professor Darn and I get done with lecture and lunch and things like that. Probably 1 o'clock would be my bet. And we'll get those on the calendar. And yes, there is a queue. So go to the office hours help queue. You don't have to join the queue. Just get the link for the meet if you want just general questions. But if you've got specific questions, add yourself to the queue and we'll check it periodically. Okay, so back to this slide. Okay, so if you do all 3 of those things, you will pass. It doesn't matter. If we mess up, it's our fault. If the exam is too easy, I don't raise the bar. That was our fault. If the exam is too hard, I will lower that bar. That was our fault. I've learned from good professors and I've learned from bad ones. When I was a freshman at Michigan Tech, where I did my undergrad, freshman chemistry 1 lab, I had, I think, a 93, maybe 94% in lab. I got a C in lab because my lab instructor didn't know the course was going to be curved at the end of the semester, and he was just kind of about grading. Oh, I think you got this. I give you the points. I don't think you quite got this. I'll take 1 point off. I had people who were getting like 85% were not passing. So I've learned not to do that. So, however, you must do each of those 3 things to pass. If you do terrible on the projects and great on the exams, that's showing me you know the information, but it doesn't show me that you can code up a project. It doesn't show me that I should allow you to go to an upper level class where 3 other group members are going to be depending on you coding your part and getting it done. So you've got to do each part separately. Generally, our lab median last semester was, I believe, an average of like 92 or 93 and a median of 95. So it is not too hard to reach those breakpoints. Our project median tends to be around 90. So they're not completely unreasonable goals. The labs. 10 lab assignments. You can work with a partner. There's going to be a handwritten part during each lab section, and handwritten during COVID days means grade scope. Writing code by hand, though, I would suggest you write it by hand on paper before you submit it on Gradescope. Why? Because it gets you used to doing it. Even if this semester, hey, we don't have an in-person exam, you don't take an exam on paper, you will be back to classes eventually. You will be taking exams where you have to write code on paper. Just start practicing now. Just do a little bit of 5 minutes, write it out on paper before you type it up. It'll get you ready for the future. So every lab will have, basically, every lab is worth 20 points. Every lab, 5 points will be this one, the handwritten code that you then type in and submit to Gradescope. So that you must do every week. It's easy points. Those 5 points are graded on effort, not on outcome. So if you put in a comment that says, sorry, I didn't have time to do this, that's not really effort. But if you wrote some code that's vaguely related to what we asked you to write, you get those points. You should be getting those points every single week. So then the other parts of it, there will be something on either the Canvas quizzes or on the autograder, or there's like a couple surveys during the semester that you'll get points for, and that'll be all in the lab PDF that tells you what to do for the lab. If you're going to be late, you're sick or something, let us know ahead of time. Lab partners, there's no need to register them, but you do have to both submit. You can't just say, oh, well, my partner submitted for the autograder, I thought I'd get points for that. No, you've got to submit every part individually to get points for it. So we're happy to have you working with a partner. We're happy to have you learning from each other, but you do have to submit individually for everything. Projects, individual work, period. Submitted to the autograder, always. That's the only way you do things for the projects. And there are 2 late days. Now, one of the things that we're doing is we have a Project Zero. Project Zero is ungraded. It's just there to let you practice using the autograder, seeing how the autograder works. And if you use late days on Project Zero, I will refund them before Project 1 is due. So that's there just so you can see how the late days system works. Basically, the 2 late days per semester, you say, I want to use a late day, and then it deducts it from your allowed late days, and then you get your full complement of submissions for that day for that assignment. So like I said, the first 2 are free, or the first Project Zero late days are free. We'll refund those. The lab sections don't matter, especially during online days. Yeah, the lab section, it doesn't matter. Even in a normal semester, we'd say, hey, go to whichever lab section you want to. So it doesn't matter even in a normal semester. So anyway, so before any real assignments are due, I'll reset your late days. However, on using late days, if a project was due on Tuesday and today is Thursday and you didn't submit yesterday, you have to use 2 late days to submit today. To show you why that's done, we'll do reductio ad absurdum, reduction to the absurd. So let's say that it's the end of the semester and you say, I haven't used any late days. I could do better on Project 1. I'll use 1 late days to submit 30 days late. No, because you've had 30 days to think about it. You've had 30 days to work on the code. You've had 30 days to run your own tests. So if you're going to submit late, it takes the number of days late to make it up. So if it's due on Tuesday, On Wednesday, you could use one late day. You get all your submits for Wednesday. On Thursday, then you could use one more late day and get a full set of submits for Thursday. But if you don't submit on Wednesday at all, Thursday will cost you your 2 days. Now, I would use these sparingly. Do not use up all your late days for Project Zero and then come back later on and tell me, but. We want, now, if illness comes up, we'll work with you. But it's hard to work with illnesses and things like that because, especially in the spring, our projects are due, assigned. So it's hard to catch up in the spring. So use your late days carefully. If something happens, medical is the most relevant example I can think of. Email the EECS 281 admin and we'll talk to you about it. Now the projects, we use C++ 17. We use GCC 6.2.0. So if it compiles with GCC 6.2.0, then it'll compile on the autograder. It's available on Cane. Our makefile will work on Cane. And if you're developing in another environment, that's great. I do most of my development in Visual Studio. But it's good to upload your files to Cane and do a make there to make sure that it compiles. Because there are things that Visual Studio will give you like, that's kind of a warning. Maybe you're not as careful as you should be. And the autograder will say, no, it doesn't even compile. So you want to be careful with your submits. I like to, when I haven't compiled in a while, I like to compile on Cane before submitting to the autograder. So we've got the autograder test for timing and correctness and memory usage. You could get the test case correct and get 0 points because you went so far over time or so far over memory. Your points degrade. The further over you are, the more they go down. You'll get immediate feedback for most of the test cases. I say most because we reserve some for final grading, but you get most of them up front. You get the hardest ones up front. You get 3 submissions per day for a normal semester. You get more in the spring. The project spec will tell you how many more. And the autograder will tell you how many you get also. We will grade. When we do final grading, we will use your best submission up to that point unless you tell us otherwise. The project spec and the autograder FAQ, if you go to the autograder FAQ, good thing to read. The autograder FAQ also has a link to the Google form of how to tell us use your last submission instead of your best one. Now I'm going to go over to the autograder. I'll switch my source over in just a second. Okay, so here's what the autograder looks like for me anyway. So I've done well on Project 1 and on the Project 0. But what I wanted to show you is what it looks like. So you've got a browse button to go get a file from your computer, upload it, and run it. These test cases here, green is good. If it goes over time or memory, it'll show up as blue. If it's bad for some reason, it'll show up as red. And there's a legend down here at the bottom that tells you what the different text means. So a number means it's how much time was used. If there's red, it'll have either wrong answer, time limit exceeded, other type of signal, etc. And look at the timestamp. If you click on this, this is the feedback you'll get when it's done submitting. So it'll tell you each test case name and whether it passed or not. What does this test case name mean? Look at the project spec, it'll tell you. So it's got all the different test cases. Look at this output, search it. Open up your search and say, I need to search for the word exceeded. Oh, look, I didn't have it. But exceeded, it'll say you exceeded the time limit, you exceeded the memory limit. Also search for the word hint. Search for the word hint appears if you got a test case like overtime or wrong, there might be a hint that goes with that test case to say, hey, have you considered this thing? So it's got all the test cases, how you did. This is your time, how much time you were allowed, your memory, how much memory you were allowed, and then your points for that. Student test files, it'll tell you how many bugs exist in our code. Test files are basically input files, not code. A valid input file to the program, and it'll find bugs. We took our perfectly good solution and added bugs to it. We want you to find our bugs. Do we really care about you finding our bugs? No, we know what our bugs are. What we want you to do is write test files. If a test file would find our bug, it might find your bug, because we wrote things that we thought students would make mistakes on. Also, all of these test files, we run not only our correct solution and our buggy solutions, we also run your solution. The first one of your test files that we notice that you get wrong, we will show you your output and the correct output. So start submitting test files early. In a normal semester, 3 weeks on a project, 2.5 weeks on the autograder, I've got people who are in office hours saying, hey, Professor Paoletti, I've been working on this one overtime for the last 4 days. I just can't figure out why I'm overtime on this one test case. And I look at all their submissions. They've never submitted any test files. I said, well, what about the test file? Oh, I'm going to do that. It's due in 7 hours. There's 10 points waiting for you to earn them, but you were working on that one test case that was blue that you lost 0.12 points on. 4 days you spent on 0.12 points, and you haven't even started on the 10 points yet. Your priorities are a little off. Go for these points early, because, like I said, if you get these wrong, we'll tell you what the right answer is for the first one we encounter. Okay, let me go back and see if there's any questions sitting there. Okay. The test files are not like 280. So the test files are actually input files to the program. And the project has a link to test files. I personally, I don't like VS Code because I don't like to edit a JSON file every time I want to change my command line parameters, but you can use VS Code. It will work. I just don't know how to use it. VS Code is actually, you're going to have to watch, I would say watch the Xcode part of the crash course video, because you're going to have to use I think Visual Studio Code has to use the Xcode redirect. Okay, where was I? Okay, so submissions, okay, before debugging, yeah. So make sure you've got submitted to the autograder, done test files. There are private test cases which we will add back in before final grading, but they will generally be files that have been generated by the same program that generated the ones you're already seeing. The hardest ones we give you up front. The handwritten, tricky ones we give you up front. No, they're always input files. They're always input files. There's never code in our test files. So there may be different, for different projects, there may be different guidelines for what goes in a test file. But for a given project, there will be guidelines for what type of test file to submit. Okay, also, so when you ask for debugging help, have submitted to the autograder is important. Using your own test files, providing your own test files is great. If you tell me, hey, I tested it on the small one you gave us and it worked, and I tested it on the 10,000 line one you gave us and it didn't work, tell me what's wrong. I don't know what's wrong. You need to find some test files that you failed that are smaller than 10,000 lines. That would help us a lot more to help you. Also, test using Valgrind. Lab is going to tell you how to use Valgrind. Use it. Valgrind is going to tell you things like you have a segmentation fault. You access memory that you didn't own. You tried to use a variable that wasn't initialized. It'll tell you things like that, and that'll really help you. Make your own test files. Yes, but the test files will be they'll be like the input that the program accepts. So like for the treasure hunt, it'll be a treasure map, and it'll have a starting location, it'll have the treasure location, it'll have some land, it'll have some water, and you'll sail around and find it. So the test file is really just a little text file with 10 lines of input in it. So writing your own test files isn't really that hard. As soon as you understand the project, you can write test files before you can even write code. As soon as you start to understand the project, you can say, ooh, what if I took your input file and changed it this way? What if I put something impassable that you can't sail on right here? Could you still find the treasure? Great thing to test. Okay, there's a screenshot of what the autograder looks like with the red and blue, etc. Old semester, yes, but picture that's got some mistakes in it. Now, here's something that's really interesting. This data is from 7 years ago, but it's still relevant because I can reproduce this graph for every semester. What this is showing is the x-axis here is when did people first submit to the autograder. And there's little tiny, it might be hard to see on the video, there's little tiny hash marks for every hour of the day there. The y-axis is the final score. So what this shows you is that, except for this weirdo here, everybody who submitted early for their first submission got a pretty good score. People whose very first submission to the autograder was in like the last 4 hours before it was due might as well have just rolled some dice to get their score. Now this person that I crossed out, I think they dropped and just never came back to it. But what you see generally is that the earlier you submit, the earlier you start submitting, the better you do on the project. You don't have to have everything working to submit our projects. Our projects are made to be done in pieces. Start reading the input. Start producing. What would you produce as output if there was no solution for project one? If you just can get that right, you might be able to get some points out of it, even before you've coded up the whole searching part. Start dealing with the command line and start working on the project a piece at a time. So what it does, what your test files catch is we wrote buggy versions of the correct code. So we have like 10, I think 12 executables. There's the correct executable and one executable for every bug. If your test file causes our correct solution and our bug one to produce different output, we say you found bug one because our program produced different output. Okay, on the yes, most recent if there's a tie, and it says that in the FAQ, I think. No, you have to do testing yourself. There's no requires, there's no grading of documentation. You just write your code. Okay, I didn't realize the... Wait a minute, this slide is outdated. What the heck, what happened here? I know I edited these slides. These exam dates are completely wrong. I know I edited these slides. I don't know what happened to the version I edited. So the dates are wrong. Let me double check my dates. So that should be 5/28 and 6/25. I don't know how I got the wrong set of slides here to show you today. I'm sorry about that. There's no false positives in ours. Either your file made us produce wrong output or it didn't. Okay, so the exams, like I said, I don't know how I got the wrong version here of that. But we've got the exam dates, they're in the schedule of topics, they're in the assignments dates, etc. Curving. So we will lower, like I said earlier, we will lower the bar if needed, but we will never raise it. We also generally will make the different grade levels more generous than the syllabus. So the syllabus is the minimum. If we decide that the exam was too hard, we may say, oh, you know what? Instead of that, 93 to get that grade, maybe it only takes a 92 to get that grade. Clarify timestamps. The timestamp is just the time that you submitted. So if you look on, let me go back a few slides. Right here, this is what I mean by the, oh, actually it just says right there, timestamp. The timestamp is the day and time that you hit the submit button. So when I say timestamp breaks ties, it would be if you've got two different submissions with a score of 100, we will take the most recent one, the most recent timestamp. Okay, where are we curving? Okay, so we've done that. Solutions be posted. Yes, for labs, they'll be on Canvas. No, generally for in-class exercises. Sometimes yes, sometimes no. For projects, never. For the exam, we might, if students make like a common mistake on the midterm written, we might go over that in a follow-up lecture and talk about like the format of the correct solution. Lectures, I would suggest going over the lecture notes before the lecture. You don't have to read them word for word and understand everything in them to have a good idea of what's going on. But you don't want to just say, oh, lecture 4 is about recursion. I'm all set. I know it's recursion. I would be somewhere between that and, oh my gosh, on slide 47, there's a formula I don't quite understand. I'm not ready for lecture. No, that's a little too much. I would go through the lecture notes before lecture, figure out what you do understand, figure out what you don't understand, think of some questions you want to ask if they don't get answered during lecture. And I realize day one here, that's hard to do, but start doing this for the rest of the lectures. It will save you time in the long run because you'll learn more in each lecture. We want, like I said, getting ready for the exam should be an everyday part of your process, not just the 2 days before the exam. Edit those notes. If you've printed them out or you've got them on your tablet, edit them. Writing things by hand, whether it's with a pencil or a stylus on your tablet, studies show time and time again, writing things by hand makes you learn them better, makes better transitions to long-term memory. Now, there's some things that we'll do in lecture that won't be in the slides at all. Someone will ask for, hey, can you do another example of that? Sure. Or maybe, hey, let's write some code. So I'd like everyone to be able to watch the videos when we present them, but sometimes, with people overseas, you may be middle of the night when we're doing lecture. So watch them, though, every day. Don't binge watch 281 the 2 days before the exam is the first time you're seeing the videos. There's only so much information you can absorb at once. When we first decided how to teach 281, we looked at how do other U of M classes teach 281 in the spring. Because when I first taught it in the spring, back in spring of 2014, it hadn't been taught in 11 years in the spring. So I looked at how do other people format their spring courses. These courses all do 2 lectures a week for like 3 hours. I said, that's terrible. Students can't absorb that much 281 at one sitting. Let's do them 4 days a week. It's just the same amount of lecture we would do during a fall or winter per day. It's just you have more lectures per week. But the per day amount we've tried to keep the same. Other instructors will tell you There's no such thing as a stupid question. And I have a very different take on that. I feel there is a whole category of stupid questions. Those are the questions that you never got answered because you never asked them. All questions are good questions. Questions show me that you've identified a gap in your knowledge. Get those questions answered. Type them in. Come to office hours. Go to office hours with the GSIs and IAs. Get those questions answered is important to you, but not asking them is the bad type of question. So, besides getting a C, besides passing, you don't want to just, get a C. You want to succeed in this class. Be serious and be organized. Stay on top of things. Allocate sufficient time for this course. This course in a normal semester could be like 20 to 30 hours per week. In the spring semester, it should be around double that, unfortunately, because there's just so much to cover, and there's projects to do and everything else. You're going to spend a lot of time on this course, and we know that. We know that this course has a large time commitment, but we do feel that you are going to get out of it what you put into it. There's a lot of work in this class, but you get a lot out of it. This is the class that makes you interesting for your internships. Interesting, why? Because you know the stuff that you need to be able to do useful work for them. Practice writing code by hand. Ask for help soon. Don't wait till the last minute. Don't take another course with this course in the spring. I know students are going to ignore that, but it's going to be a huge time sink if you're taking other courses with this. You're going to have to be really, really careful with your time and make progress on this course every day. Now, we've got a video here, which I'm going to switch my source over and start that up. And this was made by the Computing Cares group interviewing students here at U of M.
No, it does not deserve its reputation at all. I think it gets a bad rap because people are complaining about it when they're taking it, but when you're actually looking back on it, I don't think it was nearly as bad as, at least I didn't think it was as bad as people made it sound, or as I thought it was when I was doing it in the moment.
So I guess it's a weeder in that if you have bad habits, you'll get bad scores. But all of my friends who all enjoy the course and study, we do fine.
I feel like it does have that weeder aspect to it, but I don't think people should take it as seriously as everybody says it is.
Debugging, for sure, but that's always the most frustrating part and the most rewarding. One time I had a makefile that would not compile because I used spaces instead of tabs when I copied it over. It took me a whole week to fix.
I wasn't ready for the time commitment with the projects, and I also wasn't ready to ask for help from other people. With Project 1, I pretty much decided that I was just going to figure this out by myself, and after a couple of those 10-hour sessions in Hatcher, I realized that wasn't going to happen. So I would say be comfortable with talking to other instructors or things like that, because that's where I've learned the most. It's not by, a lot of the concepts in this class are pretty hard. It's fine to ask for help from someone else. So.
I didn't do so well in the midterm, and then what happened eventually was that when we moved to new content, I really started to get it, and I was able really to understand it, which was really nice. And even though I didn't know it for the midterm, I knew it for the final.
Get something correct that I've been working on for a while. I think it's just very exhilarating to type in go on diffchecker.com or whatever and put in the two outputs, and then it's the two files are identical. It's very exhilarating.
One time I wrote code. It was a pretty considerable amount of code, and it compiled on the first try. It didn't work. It didn't run correctly, but it compiled.
Oh my gosh, it was usually midnight. So I still lived in the dorms when I took 281, so there wasn't really much to go celebrate. But since Pizza House is open really late, I usually got feta bread.
I usually get a bag of Flamin' Hot Cheetos and just chill out with some Netflix.
The best meal is probably the Pizza House late night cravers deal, because you get cheesy bread or like a personal pizza, whatever you want, plus a milkshake of any flavor. That's super good.
No.
No.
I had to devote a lot of time to this class, more than really any other class that I had this semester. But at the same time, I know I'll use the tools and things that I've learned in this class throughout the rest of my technical career.
I actually really enjoyed this class. So just like, I think a lot of people kind of dread this course in a lot of ways, but like you can learn a lot from this. And I think if you just tackle with the right attitude of just wanting to go to class like every day and learn, it's actually like really fun. You learn a lot. So.
I think I'm definitely happier now that it's been like a little while, because I think I've been able to use the stuff that I learned in that class and apply it into other classes, and kind of getting the chance to like create your own data structures and go about the process of starting a project from like start to finish in really like your own creative way. I think just really translated well into what I needed to do for other classes, especially upper levels in EECS. And so I think being able to apply it later on, I look back on it and I'm like really glad that that's what I got to do.
I feel like now that I've taken 281, I really know what computer science is. I feel like beforehand I didn't really know what was expected of me, and now I do.
Start earlier on the projects.
Just start the projects like right when they're assigned.
And go to office hours. Definitely go to office hours.
To not be afraid to ask questions.
Writing variables that make sense, and especially like writing functions so that when you analyze your code later, you can tell which parts are slowing down and which parts are fine.
Go to lecture, watch the lectures, at least that pertain to the things on the project.
Starting early has a lot of benefits, especially when you go to office hours. I know I've gone to office hours sometimes. I've been there for 3 hours. I move up like 2 spots, and it's frustrating, but if I start early, I only have to wait like 5 minutes.
I know everybody says start the projects early, but when they say start the projects early, they don't mean start coding day one. They mean like read the spec, figure out kind of like how you want to set up your classes and how you want to set up all of your code. That doesn't necessarily mean you need to start coding right away, but I feel like start the project early means have a sense of what you're going to be doing for the next 4 weeks.
Okay, back. So that video, we got a link to it on the whole Computing Cares group website you can take a look at. So how many hours per week really varies per person. It depends on you, your preparedness level, how well you know the material. Planning. Planning is really important. I'll give you an example from recently. I had a student about 1.5 years ago who broke his right hand in a door, and he's right-handed. So we gave him some extra time, a couple extra days for project 3, I think. Yeah, project 3. And he got it done, got a good score on it. And then I asked him, do you need any extra time for project 4? Because, you know, we're kind of running into the final there. He said, no. He said, I don't need it. He said, on project 3, I spent so much time planning because it was so hard to type. He said, I spent way more time planning than I usually do, but I spent less time overall because I'd had such a good plan before I started coding. So it really does make a difference to plan out your code and what you're going to do before you start doing it. Study groups generally are a good idea for learning the material, obviously not for working on code. Useful tools. So make you're going to have to use because the autograder needs make, although we're going to give you a great make file with some to-dos in it to learn how to use our makefile. That's in the crash course video also. The editors like Vim or Emacs is not required at all in this course, although I think it's a good thing to learn as a long-term skill. Even if you're doing things like web development, what do you do when your web server doesn't even launch properly and you've got to log in with a terminal and edit a file, and the server is so bad, the only way to get to the server, it doesn't even connect to the rest of the world. You've got to connect to the server with a keyboard and just type things in and use Vim. Get some type of version control system is good. Make sure you have more than one copy of your code. So if you don't do these things, so we suggest uploading to the autograder. You can download from the autograder. Right next to the timestamp, there's a little button there, an arrow with a hard drive that says download my submission. So you never uploaded to the autograder. You never uploaded to Kane to test building. You never used a GitLab server. You never even copied your files to a flash drive, and then your computer dies and you look like him or her. And the funny thing is, he was in 281 the semester before I added this slide to the lecture. But there is someone every semester whose computer dies. And we don't want you to have your only version of the code on your dead computer. So an IDE is very nice because it lets you access all your tools in one interface. It lets you have your editor with your tooltip help and pop-up for what are the function parameters, some of the errors that it detects while typing, like, hey, you forgot to declare this variable that you're using. It lets you go to a function. Is there another really useful one, like, here's the function call. If I press this function key, it'll go to the code of that function, and I don't have to go finding it. Project management and make are generally built into the IDE. The compiler interactive debugger, can you do it with GDB? Sure, but it's easier to do it with the interactive debugger. Some of them have links to version control. Like, I know Professor Darden knows how to use Visual Studio, or how to use Xcode with GitLab. I know Visual Studio can do it, I'm just bad at it. Partial list of IDEs, so Visual Studio, Enterprise, or Community. Xcode, I find 2017 has been my favorite version. 2019, I've had multiple students who've had trouble getting it working. It seems 2017 is a little bit easier to get installed and working properly. So Visual Studio, Xcode, NetBeans, Eclipse, VS Code are all free, but they need a separate compiler to be installed on your computer. Plotting tools, it's good to learn something. GNUplot, Excel is probably the easiest, or even Google Sheets. Good to learn how to do plotting because you'll need it for other classes eventually. You don't really need it for this one, but it's a good time to start thinking about it. Now, before the midterm. Before and after the midterm, our focus is going to shift a little bit. I shouldn't say focus, balance. Our balance before the midterm is going to be a little bit more on the theory side. Students said last semester that it was the first half of the class was a little more like 203 and the second half was a little more like 280. So in the beginning, we're going to look at complexity analysis. We're going to look at how to do it, how to analyze it, how to do complexity of recursion, how to do building blocks, how to build up code and basic algorithms and data structures, how to implement things in C++. So even though the first half is heavy on theory, we're also going to have a lot of practical stuff in there, like how to write good code, how to measure time and how to optimize code, how to solve problems, how to approach them algorithmically, and how to select the best algorithm. The second half will do things like binary search trees, which you've done a little bit in 280, self-balancing binary search trees so that they never become too stick-like, hashing and hash tables, super important. This is going to be like your number one topic for job interviews. Graph algorithms, different algorithm types. So after we've studied lots of different things, we'll look at different categories that many algorithms fit into and how to describe how those algorithms approach solving problems. Now, data structures, we're going to need ways to store data. So like in Project 1, this semester you've got to be able to store your treasure map. And in doing that, you're going to have to use parts of the STL, and we're going to create data structures to hold our map, data structures to hold our searching information, and you're going to want to use different data structures for different purposes. Like what you store in the map might be different, should be different from what you store in your stack or queue, or better yet, your deck, your searching data structure. And some of this will become more clear after you read the spec. But what you store in the map, which is basically in Project 1, Treasure Hunt, is going to be a 2D vector. What you store in the map for each location in the map is going to have to be different from what you put in your searching, like your sale container or your land searching container. If you try to make one data type do both things, you're going to go over on memory. I guarantee it. So we want to talk about abstract data types like, hey, I've got the treasure map. How did I implement the treasure map? Well, yeah, maybe a 2D vector, but I can think of the treasure map as one of my data structures. Now, a better approach to Project 1 would say, hey, I've got a treasure hunt class, and my main is pretty short. My main creates a treasure hunt class object, tells it to go read itself from standard input, tells it to do some searching, and tells it to print out the final search for the treasure. And then I can have a class for the treasure hunt. Then inside of that, as private data, it might store the treasure map. And then it'll have member functions like do the search. Well, do the search is broken up into separate pieces of doing the sailing part and doing the land search. And then each of those will have member functions. Those member functions will have their own data, like my sail container could be part of the searching the ocean function. An algorithm is this set of directions for solving a task. Really, all useful programs, and by useful I mean beyond Hello World, all useful programs do the same thing. They all transform information from one form to another. That's what we're learning to do. That's what computer science is the transformation of knowledge from one form to another. So every algorithm does that also. It takes information in one form and puts it into another form, like a list of names and finding a certain name and telling you where it occurs, taking a list of names and sorting them. There are algorithms to do that. They have different approaches, but they accomplish the same goals. There are different sort algorithms. There are different search algorithms. They have different requirements for their data. So we want to be able to think about things in terms of, what do I have to do to the data? What have I got? What do I need to produce? So we want to think about also, as we're doing this, how long does an operation take? What is the number of steps? And we're going to talk about complexity analysis coming up soon. We'd like to be able to predict some of these answers before we write the code, let alone run it. I'd like to be able to predict what a bad choice is before I start doing it. And some complexity analysis can help us with that. when I've got a given goal that I need to meet, like speed. Is algorithm A or B better? Is data structure X or Y better for saving me memory and not using too much memory? And sometimes you can tell before you write the code, and sometimes you can't. Sometimes you have to write it before you realize what's wrong. And actually, the very first time I taught 281, the very first project, I wrote the solution, submitted it to the autograder, and I was over on memory. I went, over on memory? I'm not over on memory. I'm the professor. Oh, yeah, wow, that was dumb. That was wasteful. Yep, I went over on memory because I didn't take enough care to conserve memory, and I just duplicated information. And I went, oh, gosh, it's 2 o'clock in the morning, and I'm not going to bed until I get 100 on this project. And it took me like another hour and a half to modify my data structure, get rid of the redundant information that I was saving, and get my memory down to under the limit, and then I was fine. But it is sometimes hard to notice all those things up front. The bottleneck means the one part of the code that is the problem. So for example, in project 1, it's unlikely that reading the input takes 90% of the time. It's unlikely that producing the output takes 90% of the time. If you're over time, it's more likely that you're over in the searching part, which is the one part that's making me too slow. That's what bottleneck means. If you think about, if I'm trying to put things into a bottle, the neck of the bottle is narrower. It's the one that limits how fast I can do things. So we've got an example here, and with the spring lectures and the recordings, we might go over a few minutes beyond, like 11:50 would be our Michigan time if we were in person. We might go over a little bit to get the things done here in the spring. So what we want you to do is think about this. How could I write some code to accomplish this task? So I'm given some input, I'm trying to produce some output, and I've got an example down here, or sorry, let's add an example. It says we want the output via output sub I is the multiplication of in 0, in 1, blah, blah, in I plus 1, and in up to size minus 1. So let's do an example. Here's my input. My input is 3, 1, 2. My output, what I want to produce, is I want to produce the product of everything except that particular element. So let's just draw some boxes around this to make it a little easier. Okay, so the first entry in the output should be the product of everything but the 3. So that should have a 2. The next one should be the product of everything except the 1. That's 6. And the next one should be the product of everything except the 2. That's 3. So when I'm doing the last one here, I don't count this one when I'm producing that product. So what I want you to think about is, how'd you write the code? Take a few minutes. Feel free to type in. I'm going to turn off my mic here so I don't interrupt you. And just think about this for a minute. How would you write it? And I'll tell you, there is an easy way to write it, and maybe not the fastest way to write it. There's a faster way to write it, which might end up with some bugs, which we'll talk about in a minute. And I'll show you some code in just a few minutes. So talk about this, think about it, and we'll come back in a minute or two. Okay, well, I'm seeing some good discussion. One thing I forgot to point out at the beginning is that although I'm streaming live, it's almost live. It's about a 30-second delay between when I say something or write it and you see and hear it. So we've got some code here on the next slide for a basic approach of, hey, what if we had a double nested loop? What if I went for every input or for every output, and then we went through every input? So here's one way to do it, is we could say, hey, let's loop through everything in the array. Let's get a product of 1. Let's put a 1 in there because we're going to need a product, and we're going to be multiplying later on. And then if I is not equal to j, then we can do the product. And remember the combined assignment operator here, times equals. This is the same as out sub I is equal to out sub I times in sub j. So this is a straightforward way to do it, but the problem is this is O of n squared. If n is the size of the input, it's O of n squared. Yeah, it's terribly inefficient, but it doesn't have any problems with it. So what people suggested is, hey, what if we just calculate the whole product? But then people noticed there's a problem. What if we've got zeros? So let's go back. It's not quite always 0. So if I had, let's do another example. If my input was 302, then my output should be 0, 6, 0. So if there's 1 0 in the input, they're not all zeros. All but one of them is 0. However, if there's 2 zeros in the input, then all of the outputs are zeros. So here's the approach of, I've still got 2 loops, but let's find the product, and then let's divide by n sub I to get this particular element. Now this works great. This is O of n. Works great as long as there's no zeros. If there are zeros, then we run into problems, because then we might divide by 0, which gives us a problem. We might have wrong answers. If we get a product of everything, including the zeros, we'd say our product is 0. Well, then in this case, we'll get this one wrong. We won't get a 6 there. We'll get a 0 for our product, and then we might try to divide by 0. I'd take 0 as my product, and let's divide by 0. We can still do this in O of n time, but we're going to have to be a little more careful. We might have some more ifs of, like, when I go through and produce the product, let's produce the product of everything but the zeros, and let's count how many zeros occur. Then when I go to produce the output, if there's no zeros, I just do what it says here. If there's 1 0, I put the product where it belongs, in the one that's not 0, and I make all the other outputs 0. And if there's more than 1 0, then I just put 0 in the output. So we can do this. In O of n, we're just going to need a little bit more complicated code. We're going to need some more ifs on the input, maybe another couple variables, and then we're going to have to do a little bit more work on the output. And I'm assuming here n size is equal to n. So we did over here, we said if there's this much input, then this is the size. But if we just, let's just say n, we haven't done the complexity analysis lecture yet, but if we assume you remember some of your 280 stuff, we'll talk about it in terms of the input size n. Okay, so developing your skills. So things you want to work on, problem solving, that's what we do. Analyzing algorithms, we're going to need to do that for the lectures and for the exams. We're going to give you code. I'm going to ask you what the complexity of it is. Developing software, definitely part of the projects. You're going to be writing code and developing it and improving it, rewriting it because it didn't quite work, figuring out where your bugs are. And also important to you is memorizing things. And I don't mean rote memorization. I mean remember what you've done recently. When you use things like, say, vector, You're going to use it in Project 1. You'll probably use it in Project 2. Also, I know you'll use it in Project 4. You'll probably use it in Project 3. So vector, get used to using them, and then you won't have to look up everything about vector every time. You'll get more familiar with it from using it. Also, when you write your own code, remember what you did. Remember what you put in the data structure. And that'll save you time of going back and forth. Like, what did I put in this data structure? What did I call it? Now, modern IDEs make this a little bit easier. When you start typing like things like X dot, it'll give you a pop-up menu here and say, hey, these are the members of X. So modern IDEs help somewhat with this, but it'll also help if you remember what you did in your own code. So how do we become better software engineers? Learn when things like pointers are appropriate. In Project 1, I'm going to tell you right now, Project 1, don't use pointers. If you think, ooh, this would be a really cool way to do this with pointers, you'll find later on you're going to have to make up for the use of pointers by adding info, and you're going to go over memory. Don't use pointers in Project 1. You will get to use them in Project 2, and you will get your fill of them in Project 2. You will be sorry that you wanted to use pointers so much when you get to Project 2. And I don't mean that as a threat, but we've got part of the Project 2 is going to be using pointers, and you're going to learn them better than you ever have before. So in this class, Project 2 is usually the only place where we need pointers. Most other things I want to use instead of pointers, I want to use things like, oh, if I'm passing it to a function, hey, let's pass that thing by reference so that I don't copy it. Or what if I want to know where something is in a vector, I could use an index instead of a pointer. We want to use the STL. That's one thing that happened. Before I got to U of M 7 years ago, different professors would teach 281 every semester. Someone different would teach it. And all of them had different thoughts about what you should and shouldn't learn and use. And one semester, the professor would be like, oh yeah, use the STL in the project, use vector, use this, use that. And then the next semester, the professor would be like, no, you can't use that. You've got to use dynamic memory. And you can't use that. You've got to write your own queue and your own stack. And it really produced problems when they got to upper level classes. And the professors would be like, oh, and we're going to use vectors. You all know about vectors, right? And half the class doesn't know about them. So now 281 is very consistent from semester to semester. For the most part, we want to use the STL. And that's why there's a set of slides called Project 1, the STL and you, telling you what's important from the STL that you're going to need for Project 1. Good code versus bad code. So these are a list of things that good code should be. Good code should be modular. When I see a 800-line main, that's hard code to read. That's bad code. Can it solve the problem? Yes. Is it longer than it needs to be? Yes. Was it harder to get right than it needed to be? Yes. So good code is modular. It's broken into pieces. Better code would be, hey, I've got a main and I've got it's got 4 functions that it calls and those call other functions, and there's like 12 functions. That's good. Better yet is I've got a class. I make an object of that class. I call member functions on that class, and those public member functions call private member functions is an even better breakdown. Concise. Concise means short. Now, concise and readable are sometimes a little bit at odds. If all my variables are named A, Q, X, B, V, T, Z, very hard code to read. But if my variable names are the product of all variables in the input array, that's kind of a long variable name to read. I should get somewhere in the middle, like just product would be a better variable name than P, or the product of all values in the input range. So concise and readable are a little bit at odds, but not completely. We want to write code that's readable. Debuggable also tends to go along with these. If the code is readable and it's modular, it's easier to debug it than if you've got an 800-line main with 23 one-character variable names. I'll give you another don't right here at the beginning. Don't use pair unless there's no other choice. Don't use pair on project 1. You may be tempted to say, oh, I'll put a pair of these in there. And then you discover you need more information. What do? You make a new pair that contains the old pair. And then you discover you need more information. So you've got a pair which contains 2 pairs. And I try to read your code and I see thing.first, thing.first.second, thing.second.first, thing.second.second. And it's impossible to read. You're better off making a structure which has 2 or 3 things in it. And if you need to add to it, you still have one structure. Pairs are very, very limiting. Functional robustness. No, assertions are good, but know when your input's valid, know when it has to be checked. Know which code is going to make sure the input is valid, and know at which point you don't have to check for valid input anymore. Code reuse. If you find yourself writing the same code over and over again, think, wait a minute, I should have made a function for this. So we want to do these things to minimize bugs. If you say, oh, but there's only 3 copies of this function, well then anytime you find a bug in one of them, you have to fix it in the other 2, and you spend a lot of your time fixing the bugs you've already fixed and keeping these 3 functions in parallel. A better way would be to have one function with the if inside of it. Whoops. Okay, that's the end of our slides for today. So I'm going to stick around for just another minute or so in case there's any last-minute questions in the channel, because like I said, you're about 30 seconds behind me. But other than that, we're done for today's lecture, and I'll see you in Prof's hours later on today. Oh, great question. Yes, it's on the schedule of topics. So if you check the schedule of topics, it'll show it in there. Labs begin on Wednesday. So Prof's hours we tend to do one on many at the beginning. We'll do more one-on-ones as we get further on in the project. AutoGrader 1 and 2, no difference between them. The AutoGrader 1 and 2 are there for you to load balance. So if you find that, hey, there's 12 people submitting on AutoGrader 1, I'd go check AutoGrader 2. I might get my results a little bit faster if there's only 3 people there. Check for output or just the output texts. I'm not sure what that question means, Sai. So what the AutoGrader does is it compares your output to the correct output. And you are correct, Wyron. The AutoGrader will allow 6 people to run at a time and let the rest get queued and wait until someone's done. Yep, labs start out tomorrow, and we'll start Prof's hours today at 1 p.m. No, the Prof's hours are not recorded. Without using a submission, Shulin, watch the video near the beginning. I forget which slide it was. I talked about there's a make ungraded. I would say, Danny, do the reading before the lecture, but don't feel that you have to understand every single word of it. I would look at the slides. I would also look at the readings if I want supplemental, but most of the stuff that you need does come from the lecture slides. The spec for Project 1, Anna, will tell you, and the spec for Project 1, Anna, and also the Project 1 STL and U tells you the most important parts of the STL. So those are in the Project 1 folder. Yep, the make ungraded is just to get the files onto the autograder so we can see them. Like, hey, I made a lot of changes between yesterday and today, but I haven't submitted yet. I'll do a make ungraded so the professor can see my code and talk to me about it. It's an expensive textbook. I will not lie to you on that, but it's a textbook that you can keep forever. And you could get the printed version. I don't know if there's a online version of CLRS or not. I know the library has access to one. Bradley, the crash course video has segments on both. So you may want to speed it up during the parts that aren't you. But the Visual Studio is in there and the Xcode is in there. They're just different parts of the same video. No, Anna. You have to edit the make file to be able to use it at all. You've got to put the correct project identifier in it. You've got to name your executable. But make ungraded just makes a submission file that has no make file in it. So you're going to edit the make file just before you start using the make file at all, but then make ungraded is just built into the make file. But if you go through the crash course video, it talks about everything about the make file except for the make ungraded, which we just added like 2 days ago. Initially, we're going to add the prof's hours to the calendar. In fact, that's the one thing I got to talk to Professor Darden about and decide on. But yeah, I'll go add some for today. And then we'll get more added soon. The tarball doesn't have a way to just submit test files with no code, but if you don't have code, I mean, that would be the way to make a submission of just test files. If you just say make full submit, it will tar up everything. Any code that it finds, the make file itself, the test files, all of them go in there. So you do a make full submit would get you the test files. And if you've got no CPP files or it's just got hello world, it'll put whatever it can find in there. No, okay, I have to look just a second. I want to make sure I get the right which to-do is which. I just don't remember which one of those to-dos is first and second off the top of my head. Okay, so the first to-do is the project identifier and the executable. So in that first to-do block, the things that you have to do is you have to change the project identifier, and you've got to change the executable. The thing on the right-hand side of the equal sign are the things that you've got to do. So the second one in there, the executable, when you change the executable, that's the name of the executable file it will create. So like in project 1, you would change lowercase executable, you would change that to hunt. So it would say capital executable equals hunt. And then when you just type make, it will create an executable named hunt. The O stuff. Okay, I'm missing. Oh, the .o stuff. Yes. Yeah. The auto grader's already available, Wyrong. It's open and ready to accept submissions. Okay, I'm going to close this video, and I'll answer more questions in Prof's Hours later today.